Everyone, thanks for checking out the video. Today we're going to be looking at some postulates for angles and segments and seeing how those apply. Scrolling down, let's look at the do now. We have a segment here and we're asked to name all the line segments below. So I think most immediately many of you will probably look at this one right here, and that's line segment AB, and we would note that with an A, B, and a line over it. Also, you might notice this other segment, BC. And typically the one that people forget about the most is this long segment all the way, that includes the entire thing, segment AC, which would denote with, oh boy, that's sloppy, AC and a line over it. Okay, so that accomplishes that. Just a reminder, keep checking out Mastermind to see videos for the lessons, to get any help with something that you were missing. And that's where it's located. Okay, now the thing about geometry is it's really particular with the way you label and name certain things. When you're talking about just a physical piece, so drawing someone's attention to something, for example, you're going to label it with the line above, like we did in the do now with the little segment piece above it. When you're referring to its length, say you knew that this segment was 5 units long. Well, you would simply write it out, AB is equal to 5 units, and notice that the line is not above AB, so that's just telling you that that part is 5 units long. I know, strange, right? Why wouldn't it be the same? Well, that's an agreement mathematicians came to for some other helpful reasoning. Now you should notice that on this segment we're looking at these little blue tick marks. What are they? Well, those are congruence marks, and congruence plays a really big part in geometry, and it tells us, helps us prove theorems. It also helps us for a lot of different reasons. And we use these little marks to show that AB, segment AB, is congruent to BC. And if we were talking about the values, say this was like 5 and this was 5, we would write it out that way. But if we're just saying that one segment is congruent to the other, we use this little congruence symbol. It's the same as an equals, but just with a little wavy tilde at the top of it, and that's the congruence symbol. And simply put, congruence means equal size and shape. Okay, that's the most basic definition of congruent or congruence. So if we had, let's see, if we had a triangle, right? If we were looking at a triangle, and I put this marking, a congruent symbol there and there, that should tell you that this measure of this entire segment was the same as, or congruent as, this measure here. Now sometimes you'll see it written, let's see if I can find the helpful. Okay. Now sometimes, let's look at this parallelogram right here. Sometimes you'll see one mark here and one mark here, meaning these two segments are congruent to each other. And then you'll see 2 marks here and 2 marks here. That means that this is congruent to this one. That doesn't mean, see this long side? Since that has 2 and this one only has 1 congruence mark, these are not congruent to each other. Okay, only that these are congruent. Now, I mean, if we could prove that, sure, but using the diagram, we can't prove that, and they're not congruent to each other. Okay, let's move. So here we have some segments, right? We have KL, and that's 11 units long. LM, I don't know, some amount. And then down here, we're given the entire length. We're told that from K all the way to M is 17 units long. So how does this piece help us figure out what this piece is? Well, the long and short of it is this piece right here plus this piece here together makes this long piece altogether. So 11 plus what number gives us the entire segment? And the only thing that would make sense there, oops, the only thing that would make sense there would be 6. If this was 6, 11 and 6 all together gives a length of 17. All right, now, I remember from class, this is where some people were like, what is he doing? Same principle here. We're given one piece, we're given another piece, and we're told that all together, this entire length is this piece down here. So don't freak out just because there's algebra in here, right? Look at the geometry component. Same thing. This plus this is equal to the whole thing. And we can write an equation that says that. Okay, we can write an equation. I'm just going to use typings, might be a little bit easier. 2 plus 2x minus 6 equals, so that's this piece plus this piece equals the whole thing, x plus 2. All right? Using combining like terms and inverse operations, we should be able to balance this equation out. So we can combine some like terms over here. 2 and negative 6 together makes negative 4. So we can get 2x minus 4 equals x plus 2. We could subtract x from both sides. If I subtract x from over here and subtract x from over here, we get x minus 4 is equal to a positive 2, because these ones cancel out and 2 is left over. Okay, last step. The only way to solve this and isolate the variable is to add 4 to both sides. Add 4, same thing to the other side, add 4, and we get x equals 6. There we go. So as a double check, 6 plus 2 should give us an 8. 6 times 2 is 12. Minus 6 is 6, so this whole thing is 6, and 2 is 8. Hey, it matches up, as it should. So we know that the value of x is 6, but the question says find the length of CD, which we did over here, 6. It all works out. Okay. So, what did we just look at? Why were we able to do that? Well, a long time ago, mathematicians came up with this postulate, the segment addition postulate, and this is the long, complicated stuff. It's pretty convoluted. The easier version, segments add, like we just did. You can add segments together that are collinear. And therefore, in the same regard, you could also subtract them to find missing pieces. Works out. Let's take a look at these angles. How many angles do you see in class? Some people said angles ADC was 1, so this obtuse angle ADC, that's 1. There was also another angle BDC, this acute one, right up in here. And then the one people commonly mistake or forget is the straight angle ADB. That's this straight line right here. And how many degrees is in every line? 180 degrees. That counts as a straight angle. All right. So a little bit about notations. When we're talking about the degrees in an angle, like pretend that this angle was, I don't know, 110 degrees. When we're talking about degrees, this says the measure of ADC is equal to the measure of ADC. That means their degree measurements are the same. When we're talking about just saying that the shape or the angle is the same, we write it without the measurement piece and we use the congruence symbol. So I know it's a little finicky, but we'll get better as we go on throughout this year. Okay, so here we go. We have an angle. It says to find the measurement of x, y, z. So here, let's use green. We're trying to find this big angle right here, x, y, z, and we see that z, y, w is 105, and x, y, w is 30. So together, these two make up this big angle here that was highlighted in green. So if I can put these two together, 30 plus 105, that's going to give me 135 degrees is the measurement, right up here I could even say, the measurement of XYZ angle is 135 degrees. Does that work for other things? Sure. Can we do it backwards? Like say I had an angle here, and I tell you, let's put in some markings, and I tell you that the whole thing, so the big angle here, this big angle, let's pretend I said that was 100 degrees. And then I said this little part of that big angle here was 60. Would you then be able to figure out this angle right in here, how large that is? Sure, if the whole thing is 100 and this smaller one is 60, this leftover piece has to be 40 because together they must make 100. What allows us to do this work? The angle addition postulate. It says that angles add up, and if they're together on a straight line, then that straight line is 180 degrees. There you go. Straight lines 180 and angles can add up. Just like segment addition postulate says segments can add up. Cool. There's some really important angle pairs we're going to be using a lot this year. One of them is vertical angle. So if I had, let's put some lines here. Okay. Let's change the color, make it pop a little bit. Okay. If I had two intersecting lines, vertical angles are on the opposite sides. So this angle here and this angle here are congruent to each other. That's what makes them vertical. Likewise, this angle up top and this angle down here are also congruent to each other because they're vertical. And we'll get into more of that later. Okay, so just had to put that on pause. Let's pick up where I left off. Where was I? Adjacent angles. Adjacent angles are two angles that are right next to each other. So this angle is adjacent to this one right here. This angle here is also adjacent to this angle. However, this angle is also adjacent to this one. Okay, so adjacent, simply put, just means next to. Adjacent angles are next to each other. Complementary angles are two angles that add up to make 90 degrees. So if I have 90 here, and this one is, I don't know, 40 degrees, how large does this one have to be so that they add up to 90? Well, it's got to be 50. How do I know that they're complementary? Because there's this 90-degree angle marking here. So 40 and 50 together make 90. Supplementary angles add up to make 180, and we know that straight lines are 180 degrees. So if we have two angles that are adjacent to each other on the same straight line, we know together they must make 180. So if this is 110, how much does this angle be? And I know this isn't drawn to scale, so just bear with me. This angle would have to be 70 because 70 and 110 make 180. I had a student one year who told me that they always got them confused. They always thought complementary was 180 degrees and supplementary was 90 degrees. And then they came up with a solution, which I thought was pretty neat. So if we're looking at C and S, C for complementary, S for supplementary. Complementary makes 90 degrees. Supplementary angles make 180 degrees. I thought that was a really cool trick, and it just goes to show you whenever you have good memory tools, use them, and also be sure to share them because they might work really well for other people. So that's all we can get to today. Please tune back in for the next lesson, and we will move forward. Check back soon.